Hey guys, welcome to the next channel. So few days ago I shot a video episode on NetTools Ifconfig Command. So in that episode I gave a quick overview of the architecture of the same. I did also a sort of quick code walk, and in that I have described I mentioned that sometime down the lane I may do a detailed architectural high-level design diagram in Google Diagram, and I'm going to share the same just the way I have done with iputils ping command. So if you go here, I have done the similar approach. So in this case I have done this quick architectural diagram. So I have not mentioned the various other helper APIs. I have mentioned the basic flow and also important APIs, so that we will get that big picture, and then we will also understand the architecture of how it has been implemented. So in that way, if you go here, this is the first episode what I discussed. So in case if you haven't watched my first episode, I kindly suggest you to watch the same, because I have described various things whichever I have described in my previous episode, I may not much in depth describe in this current episode. So I highly recommend you to watch the same before watching this video. So having said that, if you hop on to the source code, in the first episode I have only discussed about ifconfig .c source alone, but the story doesn't end over here. So in this source, if you notice in the top, it includes all these files. So all these header files are you can find it in netutils under include folder, and the implementation of these .h files you can find it in lib folder. So you can see here, so in the lib folder you can see various .c files. In that we just highlight a couple of them so that we will get the complete picture of the same. So that way, if you go through the same, one of the important things which catches my attention is interface.c and its corresponding interface.h. So if you are into kernel space programming, and if you follow my old video episodes, you must have stumbled across the net device data structure. So net device data structure is the way kernel maintains the interface list in its data structure instances. So if you see in the net device data structure, you can also find another data structure which is holding the statistics of each interface. So similar thing happens over here as well. So you have this interface.h, which contains a data structure which holds the interface stats, and then the main interface instance which has this all the details of the interface. So you can see here interface name, MTU, and IP address, gateway, and all the details are associated with the same. So as a part of that, you can also see it has this user net device stats. You can see here it has been also associated with the interface instance. So this way, this is how the data structures have been organized. So this is what essentially you get if you do an ifconfig command. As you can see here, you get this stats. So essentially what is happening is it is pulling this parameters from the kernel space to the user space, and it is displaying in the ifconfig command. So if you now traverse the source code of ifconfig.c, okay, we can go down and we can see here it has a few of these APIs, ifprint and set flag and clear flag. So some of these things I have discussed in the previous episode. So you can go down and you can see here it has this main, and as you understand ifconfig command, you can print the interface details. You can also set any of these attributes corresponds to that interface, like MTU, its IP address, net mask, and stuff like that. So you can read the various attributes of this interface. At the same time, you can also set the attributes of this interface. So but every time you try to set these attributes, you need to have that sudo permission. Hope you know about the ifconfig command. So this is what essentially is happening. It is taking various parameters and it is parsing the same, and based on the parameters it is just doing the corresponding action as the way it is registered in the main API. So you can see here So below that, initially you can see here it shows this version usage and all that stuff, so which is what I have just represented in the picture. So this is not that much useful, I just represented as a part of reference so that you see that you have this main API and it has this sort of a flow. So with that we have this usage. And next thing is, if you generally do if config, it displays the interface information. So you can see here it has this if print API which is called, and the same API is called in some other circumstance. Let us not go in depth about the same. So you can see here if print is called, and below that you have various other parameters, like if it is an ARP, then it is displaying or printing the same, and various other stuff. So you have this clear flag, set flag, if it is ARP versus if it is hyphen ARP or minus ARP, it is doing a reset of the same and setting of the same. So this way it is doing for various other attributes as well. So let us not get into the same. Let us quickly walk through how it does if config generally that print of port information. So you see this if print. So we can search what is the source corresponds to the if print. So you can see here its source is over here in the same ifconfig.c. For that, what it does is initially it traverses across all the interfaces. You can see here it traverses all the interfaces for all interfaces, and it does this do interface print. And below that it also has this look interface and do interface fetch, and then it does this interface print. And in each of these instances it uses interface instance as its the main function argument within the same. So that way what we can do is that way what I have done is I have plotted the hierarchy of these APIs in this way. So you have this if print, and if print needs this, it needs it does further down below somewhere these APIs. So that way what we can do is, if you trace for all interfaces and do interface fetch, before that if you trace for all interfaces over here, so you have this implementation somewhere here. As you can see here, it is in interface.c, not in the ifconfig.c file. So in the interface.c you can see here it has this source, and actually it has this function which is sent as a function argument or something like that. So in that way we need to see the source code of do interface print. So before even doing the interface print, it needs to get it needs to fetch the interface details of this interface. So that way what happens is, so anyway you can just search do interface print, and even as you can see, as I said before, even before doing that it has to fetch the interface details, and then it has to show each of the interface details over here, interface print. So that way we can go to do interface fetch. So if you find the source, it has this source, and inside that it is calling if fetch. So if you go inside if fetch, okay, you have this big API. So this API has that entire flow. You can see here it is fetching various attributes. For example, you can see here it is getting the interface MAC address with respect to interface name. You can see here IOCTL. So as usual, you understand whenever it fetches this parameters from kernel space to user space, it uses this IOCTL API. So this is what exactly I have discussed in my previous episode as well. So it gets through IOCTL, and in this case it is getting the interface hardware MAC address. So that is what is if hardware address, and before that it has this system IOCTL. G stands for get. So system IOCTL through IOCTL get interface hardware address. So this is what is the command. So it is getting this hardware address, and it is populating in this interface in the instance. Interface E is the instance name, interface E, IFE, and it has this hardware address. So if you go to interface.h, you have this somewhere you will find the hardware address member variable. You can see here it has this 32 bytes have been allocated, although in the case of Ethernet it is just 6 bytes. It has this 32 bytes have been allocated for the same. So that's is what essentially happens, and it is just repeating for various other attribute or parameters as well. So that way, if you come down, so what happens is down the lane it is also doing a lookup of interface. If you go here, you can see here it has this lookup interface. So if you go here, the source of lookup interface, so it has been implemented in interface.c. So you have this inside, it calls this API interface read list of proc. So essentially, hope you know that this has interface statistics and various other things is also represented in put forward in proc file system. So you can also read from the proc file system as well. So you can see here interface read list through proc, and it is doing the same. So it is getting various statistics of the same, and it is trying to populate in the same. So you can see here this is the API. So you can see here it has this proc, and it has this get dev fields, and then it is doing an add interface, and somewhere down the lane. So add interface, if you go to the source of the add interface, it is essentially doing this, it is adding this as a part of the linked list chain of interface instances. So this is what it is doing. So I don't want to go too much in depth as I always do, because this is a literally quite huge source, just like even that old ping command. So it's quite literally huge. As far as I got that mental map, I'm just sharing the same, and in case if you are a beginner, this is how is the approach you should do. And once you get this level of understanding, you should go to other phase where you need to understand even more why it is doing the proc, why it is not, it is anyway done in earlier in some other way, why next it is doing through the proc and things like that. So you can go in multiple levels, and you can get more details. Sometimes you may have a situation where you may work in a company and you need to change the source code of Ifconfig command to customize, and you may work on some SDN projects. You need to add some features in this Ifconfig command. So in that way, or you may have some virtual instances of interfaces, and you need to add some features for those virtual ports, a special virtual ports which you add through some kind of a device driver which you inserted in your custom kernel. So things like that, those are the cases you may need to touch the existing Ifconfig code, and you need to come up with your own revised Ifconfig source. Through the source you get Ifconfig command. So that's what it is. So anyway, we can go through the same. So you have this add interface. Essentially it is finally it is populating the same, and if you go back again here, it is somewhere doing this interface print. So we traverse this API source. So it has two variants. If you go here, do interface, let us just go to the API. You can see here it has two variants, interface print, and it is taking that interface instance. So inside it has this, either it should be printed in short format or long format. So totally you have these two branch out of APIs, whether it is short or long. So somewhere here I want to also discuss about how it populates the stats. So in this case you can see here in interface print long, it is converting various raw data into in the format of MB, KB and stuff like that. It is just changing the units of notation of this stats. So you can see here, but we can also see how the stats are getting populated. So let us just search stats, and we can see in which place it may likely get populated. Yeah, you can see here get device fields. So this is what is the API which I have represented here, get device fields, and this is where it is getting this statistics from. I believe it is getting through proc interface, and it is procnet dev, and it is populating in that data structure. So if you know the proc interface, it has this somewhere. I'm not sure about which exact file. Cat dev. So if you see here inside procnet dev, this is the file. It has this stats populated. I think from here it is pulling up the stats and it is pushing into the data structure. You can see here it is doing an scanf, and I think it is pushing into the data structure. So this is where essentially the data structure user net device stats is getting populated, and this is the reason I just mentioned the same in this architectural flow. So this way it gets the statistics, and finally in the case of interface print, it prints the interface parameters as well as the statistics, everything together as a part of basic Ifconfig command output. So with this I think I can conclude the code walk and the architecture of Ifconfig command. So you should understand, I have not gone through various other stuff like sockets.h, and there is something called as mii.h and ipx.h. As you can understand, it is quite it has this nominal code. I'm not sure in the case of ifconfig exactly where exactly, like in this case util -ank.h is utilized. Maybe somewhere it is used as you understand, like it has this various helper APIs like get underscore u32 and do IP address and do IP route and stuff like that. So these are various helper APIs. Maybe somewhere it is getting utilized inside ifconfig.c. So this is the reason I have not highlighted about these various other include files and also its corresponding source. You can see here. So this is quite enough for us to understand this basic high level design architecture of the same, and this is very important. Let me just correct the same. So this is quite important if you're a beginner to do a sort of code walk and come out an understanding of this code walk and how you can further add any changes to this existing code in case if it is required, and also you can use the same practices to any other existing project, and you can try to understand what they are trying to do as a part of the implementation to get that whatever desired output. So hope you guys loved watching this video. If you have any questions, if you want to reach me, you can send an email. So thank you once again for watching this video. Have a nice day. Bye bye.